Today, on how it's made. Fish replicas. Siren systems. Prepackaged sandwiches. And candlesticks. It used to be that you stuffed and mounted that big catch. Nowadays, catch and release is the norm, so the trend is to display replicas of the prize fish you caught, photographed, then set free. It's more humane, and you get to brag about the one that didn't get away until you let it. Sports fishermen aren't the only buyers of fish replicas. Marinas, seaquariums, and seafood restaurants also acquire them for display. While a replica is a humane alternative to mounting the real thing, one real fish does have to sacrifice his life for the cause in order to make the mold from which the replicas are cast. The first step is to surround the dead fish in a mix of soil and dirt. To construct the first half of the mold, the artist builds the mix up to the halfway point, then rinses the surface clean. Next, using molding plaster, he forms a ledge all around the fish and under the fins. He positions 6 to 8 tabs that will help align the two mold halves. Once the plaster hardens, he pins the fins steady and pours on gel coat resin. This material picks up the scales and other intricate details. Once the gel coat cures, he removes the pins, then covers the surface in fiberglass resin, and over that, shredded fiberglass cloth. Then he applies another coat of fiberglass resin, ensuring the cloth is thoroughly saturated. Once the resin hardens, he flips the fish to the other side, breaks off the plaster, and repeats all the previous steps to construct the second half of the mold. After about 4 hours of labor, the mold is finally finished. The mold maker removes the fish and washes the now vacant cavity. The team can begin casting the replicas. They wax the cavity to prevent sticking. Then they apply white gel coat resin, which picks up all the fine details. With a handheld chopping gun, they lay down a layer of shredded fiberglass cloth. They apply resin putty along the perimeter of the cavity on each mold half. Using the alignment tabs, they close and clamp the mold halves together. Once the putty sets, they remove the clamps, open the mold, and extract the fiberglass replica. Using a jigsaw, they cut out the fish's mouth. Then, via the mouth, they fill the hollow interior with expanding polyurethane foam. The hard foam provides a solid base against which to sculpt the fish's mouth and set its eyes, fins, and gill. With the jigsaw again, they remove all the excess foam. Then, with a disc sander, sand the rough edges smooth. Next, they glue a glass eye on each side of the head, and, using resin putty, set the side and bottom fins, which they had removed at one point, and molded separately. They epoxy teeth into the mouth. The mold maker used the real fish teeth to make a rubber mold. Then, using that mold, he cast this replica set of teeth in plastic. Now they'll bring the fish to life with color. First, using a paint gun, they apply a coat of gray primer. Once that dries, they apply a white base coat, followed by a coat of silver. With an airbrush, an artist paints the subtle shades and markings that make this fake fish look so incredibly real. The finishing touch? They paint a piece of cardboard red, cut it into the shape of a gill, then glue it in place. After 4 to 5 hours of casting and painting, this prized catch is ready for display. Siren systems were first widely used during World War II to warn of possible air attacks. Early on, that wailing effect was generated by forcing air against a perforated disc. Today's siren sounds emanate from higher-tech systems and still mean trouble is on its way. From atop towers and buildings, siren systems warn surrounding communities of impending tornadoes, floods, or any calamity. Today's sirens can broadcast both warning tones and live voice messages. They can also be activated by remote control from anywhere in the world. The messages and warning tones from a typical system can be heard from almost 3/4 of a kilometer away. Production begins with the transformers for the amplifiers. A worker winds thick insulated copper wires around a plastic bobbin to produce the transformer's primary coil. She compresses the wires to eliminate gaps. A tight winding is critical for generating a magnetic field and transferring it to a secondary coil. She wraps insulating tape around the primary coil. She winds thin wire over it to produce the narrower secondary coil, and she encases that in more insulating tape. Next, with swift dexterity, an employee stacks E-shaped iron insulators in the center of the bobbin to build a core. She inserts smaller iron insulators between the E-shaped ones, and this tightens up the pack. She taps them into place and now has a dense iron core that will aid the flow of energy between the transformer coils. With an enamel coating baked on and the assembly wired for sound, this siren transformer is now complete. A computer-operated machine now punch cuts assembly holes in an aluminum panel that will be used for a section of the siren cabinet. A robot transfers the panel to a computerized bending machine. Another robot feeds the panel to a clamping bar and, using hydraulic might, bends it against the clamp in strategic locations. This transforms it into a section of the siren's back and side walls. It also folds the edges, creating flanges for the cabinet door assembly. This computerized system takes less than a minute to complete all these folds. The robot then transfers the siren cabinet part to a conveyor, and it's on to the next station for assembly. Ahead, some cabinet brackets are in the wash zone. As the parts travel through, they get a soapy spray and then a rinse. After drying, the parts head into a powder paint booth. Sprayers apply dry powder paint to the surface of the parts. It takes 8 automated guns and 2 manually operated ones to evenly coat these brackets. The paint is electrostatically charged to cling to the metal, but at this point can be rubbed off like dust. Baking it causes the particles to melt and bond to the surface for a smooth and very tough paint job. This worker now installs the siren system's control board. It regulates the siren's 6 tones, 16 pre-recorded messages, and the public address function. He bolts it to the inside of the cabinet door. Next up is an amplifier equipped with the transformer we saw assembled earlier and the amplifier board. He installs the completed amplifier in the cabinet and connects it to the control board. There are 5 amplifiers in this siren system, one for each speaker on the tower. He equips it with a control pad for on-site activation. Then a 1,500-ton press injects hot liquid plastic into molds. In seconds, the plastic cools, and the press retracts to reveal the new speaker parts. They bolt the speaker house together, install the screen through which the siren sound emanates, and top it off with a plastic cap. They install a 400-watt driver in each section of the siren's speakers. The more speakers there are atop the siren tower, the greater the reach. The most powerful can be heard many kilometers away. Emergency vehicles are equipped with smaller versions of these systems to warn motorists of their speedy approach. The concept is basically the same, to get your instant attention. In today's hustle and bustle world, it's not uncommon to forego brown bagging it and instead to grab a meal on the go. It's not surprising to see that food retailers, from mega supermarkets to tiny convenience stores, carry pre-packaged sandwiches for the hungry-in-a-hurry customer. Ham and cheese, cheese and tomato, chicken salad, just a few of the many sandwich varieties you can buy ready-made. Retail customers specify which ingredients they want in their sandwich order, and the factory sets up the assembly lines accordingly. The first step is to load fresh bread into an automated machine. While doing so, they visually inspect the slices and remove any with holes or other flaws. The machine separates the slices in the loaf. Then, because the sandwich requires it, an internal roller spreads melted butter. The machine then drops the buttered slices face up onto the belt that moves through the production line, where first, an automated depositor squirts on the quantity and type of mayonnaise the customer requested. Workers manually lay on the more specific ingredients, such as cold cuts or grated cheddar cheese. In the prep area, workers load logs of ham into a slicer. The customer has specified the size and weight of the slices it wants in the sandwich, and the factory programs the slicer accordingly. The slices go off to the assembly line, where workers add them to the sandwiches. Next, they close up the sandwiches. They stack the sandwiches in piles of 2. The belt then brings the sandwiches to a mechanized cutter. The cutter works like a reciprocating saw, the vertical blade oscillating at high speed as the sandwich travels through it. The stacked halves on each side will be packaged together as one sandwich. Some of the sandwich varieties produced in the largest quantities are made on a fully automated assembly line. A robot suctions up bread slices and places them on a moving belt. Positioning plates descend and adjust the slices so that they'll be perfectly centered under the nozzles which dispense the sandwich ingredients. In production here, egg salad sandwiches. A nozzle deposits a set quantity of chopped egg with mayonnaise on every second slice. At the next station, robotic arms lined with suction cups grab the empty slices and flip them over onto the filled slices. Next stop, an ultrasonic knife. It slices the sandwiches in 2, using vibrations produced by high-frequency sound waves. This cutting method gives a cleaner edge. Next, robotic arms pick up half of each sandwich, spin it around, and stack it onto the other half. A robot grabs 4 finished sandwiches at a time and puts them in triangular plastic trays, which then move onto the sealing and labeling stations. Back on the semi-automated assembly line, workers stack the sandwiches manually and place them in individual plastic-lined cardboard packages. A conveyor belt brings them to a machine which pushes down the top flap and heat seals it shut. The sandwiches hit store shelves within 12 hours of production. They stay fresh for an additional 3 days, after which the sandwich company removes the unsold ones while making its daily delivery of new ones. Before the invention of electrical lighting, candlesticks were household essentials. They often had shiny flanges to reflect the light of the flame and throw the glow farther. Necessity may have been the reason for their invention, but candlesticks soon evolved into a thing of beauty. With their elegant curves, these pewter candlesticks add a touch of class to any decor. Top them off with lit candles and the ambience improves, which is why people still use candlesticks to both decorate and illuminate. This candlestick starts with a flat pewter disc. The worker stamps the company insignia onto it. He loads the stamped disc onto a lathe against a flared form known as the chuck, a kind of template for the base of the candlestick. He rubs a wax-like lubricant onto the pewter to reduce friction while he works the metal as it spins very fast on the lathe. He exerts a fair amount of pressure with a finger-shaped tool to make the pewter conform to the shape of the chuck. This process is called spinning. It takes a series of passes with the tool to transform the flat disc into the basic shape of a candlestick base. He trims the bottom to make the part perfectly level. Now, with a wooden dowel, he rolls the bottom of the candlestick base to make it more substantial. The base now complete, he sets it aside. He works a smaller pewter disc against a different chuck to shape the candlestick top, which is called the babèche. He flares the babèche, creating a flange to reflect candlelight and catch wax drippings. Using the chuck pictured on the left, he's produced a stylish candlestick top. To make the candlestick post, the next worker melts pewter and skims off the impurities. He pours the molten pewter into a mold and it solidifies quickly. He drains the remaining liquid pewter and opens the mold, revealing a hollow post that matches the top and base of the candlestick. Pewter has also hardened in the channel through which it was poured. This extra material, called sprue, will be removed later. Over at the next station, a worker removes a seam-like ridge created where the parts of the mold came together. He scrapes and files the ridge to even the surface. On the left, you can see the candlestick post before the ridge removal, and this is the part afterward. Another worker now slices off the sprue ends with a bandsaw, leaving the post design intact. The pewter sprues will be remelted and reused. Next, the worker clamps the post into position, and a paddle drill bores into one end and then the other. It slopes the lip of the casting inward, creating a chamfered edge that will connect neatly to the candlestick top and base. He slides a rod through the casting to better grip the part as he presses it against a fine grit sand belt. The sanding process removes scuffs and scrapes, and the result is satiny smooth. Now it's time for this pewter candlestick to come together. He places the post on the candlestick top and solders them together. The tin alloy solder wire melts and acts like hot glue to bond the two parts. He moves the candlestick base into position. He dips the open end of the cast post into a flux substance to prepare the surface and transfers it to the base. As he solders the two, he taps the post with a torch to realign it when it slips a bit. Then he continues soldering. He now dips the completed candlestick in soapy water. This removes flux residue and hardens the solder bond. For a highly polished finish, he presses the candlestick against a spinning cotton wheel that rubs a special compound onto it. It's a shinier alternative to the satin pewter candlestick, and the effect is similar to silver. When it comes to candlesticks, two are always better than one. So it's time to pair them up. Together, they'll really shine.